sentence.
Welcome on my presentation. Today I will talk a little bit about Docker base images and how to manage them, sharing some good practices, bad practices, something in between. Hopefully you will enjoy. My name is Tomasz Gągor. I am people lead and DevOps engineer at Zooplus. I have something around 15 years of professional experience in IT. Half of that time I was actually working somehow with either Docker images, Docker servers, managing them, doing things around. Right now I'm part of core application and technology services team, for short CATS. And this team is helping other teams, development teams, to deliver their stuff. Do we have here any Zooplus customers? Do you know the company? Please raise hand. Nice. Wow, quite a lot of people. Good to see you. For those who didn't know, I will do a short introduction. So Zooplus is the European pet e-commerce leader. Like we're the #1. And you can think about the company like Zalando or Amazon, but on pet related market. Just from the perspective how big we are, we're not a simple shop. We are working in 30 countries. We are available in multiple locations. We have 11 fulfillment centers or warehouses, which is quite uncommon. And in general, we have more than 1,000 of employees. I don't want to focus too much on that. We have more topics to cover. But before that, I would like to know a little bit about you. I will try to focus on the topics that might be more interesting for you. So my first question, do you work with Docker containers on a daily basis? Please, hand up. Okay, so more than a half, thank you. How many of you are considering themselves as developers, software engineers? Okay, quite a lot. And maybe the other part from the operations, DevOps, SRE, administrators? Okay, only a few. Okay. I will do my best to cover what might be interesting more for you. So, agenda is quite simple, but there is more hidden between those points. So first, tell me from the IT perspective what the scale we have, what we are working with. So we have something around 40 product teams, IT teams doing development. They handle around 300 products. Products are just applications or sets of applications. This is quite a lot, at least in our meaning. What makes trouble here is that we take full from DevOps culture. Every development team is fully responsible for the stack they are building, just from the inception through development, testing, monitoring, alerting, till the decommissioning. So they do all the things. They not only develop the code, they also manage the cloud infrastructure, at least part of it. They also build containers. They are responsible for deployments daily. Because of that, they cannot do this obviously alone. And there are teams like mine which are providing them some tools, libraries, best practices, Terraform modules, and part of that is providing them set of base images for Docker containers. And today we will be talking about that. In case of Docker images, we have more than 50 base images, I think 53, maybe 54. All of them are available in 4 flavors. That's how we call it. So generally it's the same image, but it behaves differently. And those 4 flavors are just available for teams to decide if they want it, if they need it. This eventually means that with every build, we actually build more than 200 of Docker base images. Maybe a quick question. Do you know what base images are? Not the Docker images, but the base images. Okay, one person, not much. So just short on this one. From Docker Hub, you can actually download a lot of base images like Ubuntu or CentOS, but then you probably want to add something more to this, like some framework support, some server and things like that. So what we are doing, we take just pure OS images, and maybe the next slide will help me to that. So we start with a base. Usually it's, in our case, it was CentOS. We are switching right now to Ubuntu. So this tree is actually just showing the generic structure. It's much, much bigger. It was just not point to provide all of that. And from this base OS, we are adding layers and layers that are adding more and more functionalities. And those images in the end are the images that development teams use during the development. How we do that? Because most of our applications, like around 80%, is somehow either written in Java, Scala, or generally running in JVM. Jenkins was our obvious choice. Jenkins spin dynamic agents, so they are created every time the pipeline starts. And each of these agents is running as a Docker container, and it's also running Docker server inside. This is how we call it, Docker in Docker. What might be surprising here, we also use GNU Make in this process, and I would like to tell you something about why. Make, you might remember from those old interviews, like people were asking, do you know how to build a package, right? And actually it's old tool, but it's really nice. It handles a lot of the stuff out of the box, and it does something that is just hard to do with plain Jenkins files. Because you cannot really easily run Jenkins file locally. You have to start Jenkins, use some kind of virtualization. It's not convenient if you have to work with 200 of images. And this is where we used Make. So we have just some of the simple commands. And with those commands, you can just call specific steps, layers, or stages that we use during the build. So Jenkins actually just calls few Make instructions. How does it look like? We really like how this quotation equation sign work, because it's like a ternary operator. So all of those variables might be defined on a Jenkins side or locally. And when you have this, it's just feeling really nice. And this is functionality of Make. With Bash, we have really terrible script, far more terrible than what you see here. This one is quite simple. And we have definition of stages. We can call either all the images on specific layer, specific image. It's really one command that you call. And you can call really complicated commands to build that, but on this will be later. I would like to share with you some of our pain points, things that we've been fighting since beginning. So I'm not proud of the first topic here, root by default, but generally, if you think about base images available on Docker Hub, many of them still run whatever you run there by default as a root. And if developers use that, this means that they use super user for daily stuff. It's not secure, we didn't like it, and we have to do something about it. The other problem that we have was that we have some kind of versioning, but just from the version change, you didn't know how much it will exactly change. If this is a big change, if not, because they were happening accidentally. Like someone asked you to add new version of Python, you added version of Python, upgraded Java, and dropped something that was old. And it was causing a lot of surprises. Another issue that we had was that from the security perspective, no one was looking at, oh no, hide, killed. From the security perspective, no one was really looking if those images are fresh, how often they should be built. So we've been building them when someone requests, and if no one requests for 2 months, it wasn't nice. Other problems were just kind of nature of the Docker files. I told you about 300 or more developers that we have right now, and they manage tier Docker files for tier application daily. And you can foresee that not all of them really know how to write Docker files properly. So they just take the file, copy something, or use Stack Overflow. Yeah, it's working or it's not working. It's just easy to write Docker files. You don't have to read documentation actually to do this. The results of that are that those images are not optimal, sometimes not secure, and for example, they might also collect some garbage, like they are downloading files or changing permission, creating multiple layers. Those images are huge. They are downloading slow, starting slow. We have also some troubles to determine what version of base image application used. So imagine the case. Today you are deploying something, it's not working, but it was working day before, or week before, or 2 months before, depending where you've been building the application. And you would like to know which version was working for you. But how to know that if you just use some of the images without knowing the commit, the version, etc. So what you usually do when you have troubles like this, you are looking for some kind of solution. And you start looking at best practices. You go through the internet and looking one page, another page. There's a lot of best practices, many people that want to advise you, but are those really best practices? Do you know those people? Do you know what scale they have? If they have 5 base images, it's not comparable to 200. So we tried to follow those best practices really hard, but sadly, some of them, even really popular, were just not working for us. And right now, I will try to share with you what we did and what was working for us. We will start with some simple things. We are saying bye-bye to the root user. And the best practice, even in official documentation, say to use user directive. There's a problem with user directive. When you declare, for example, imagine Tomcat image. You have Tomcat image, you have Tomcat user, you drop privileges from root to the Tomcat user. You push this image, developers use it. And what will happen? They have to add some files. They are adding files, they need to change permission. They don't have rights for that. What they do? They change the user from Tomcat to root. They change permission, okay, it's working, push. Went for production. Do they remember to change the user back to Tomcat? Honestly, I didn't saw a single person doing that. So for us, this command wasn't working. On the other side, if you try to work with user, it's just breaking your stuff that was working on root. So many people just will keep running root. What we did, we used Gosu for that. Gosu allows us to run application as unprivileged at the last stage. So through whole build process, you have root permissions. But when we add entry point with Gosu binary, we are dropping privileges. And since that your application is running in unprivileged mode, that was big difference for us. After every section, I will share such small summary. So I would recommend to use Gosu instead of user. It's just working better and it's harder to break because you have to really think how to turn it off. Not like with user, you change it and it's not working for you anymore. Another easy topic that we solved was providing metadata. There is something called Docker label schema. Actually, it was draft for something that became OCI image spec. It's all about providing some additional labels. you might remember from the makefile that I showed you. Just put things like that in your build pipeline, and you know when image was built, from which version, which Git branch, which commit, and you can provide more labels if you need. And those labels are sticking to the base image. Any application that will use this base image will keep the labels. They might also manage their own labels if they want. So this is really a low-hanging fruit to use that. For that, I also advise to use semantic versioning, but I think I will tell about that a little bit later. One of the things that, or best practices that didn't work for us well, was to pin the version of images. It's really common best practice if you look over internet. You should pin Docker images to specific version. Why? Like we actually say something opposite. We encourage developers to use latest always. We try to provide only incremental changes. Thanks to that, there are no big surprises for them. And we also provide some versioned images, like we use semantic versioning. Semantic versioning is 3 numbers separated with dot. First number is a major change, second minor, so should be compatible, but it is a bigger change or refactoring. And third one, patch level, no changes, just some fixing something that's not working. With this change, actually it might happen that sometimes things will be broken more often. Because they use latest, changes are propagating faster, and it just might happen that your build will be failing. But we accept this risk, and we actually tell people that if you are under strict time conditions, you have to deploy today, you can do this, pin to older version. But we only support, as a team providing base images, the latest variant. So remember about putting this on your next sprint and find the way how it's working. We also help with that, so it's not a big deal. With this push to latest, we are doing something more, something which we call QPD, or quarterly patch day. Every quarter, we spend one sprint providing upgrades for all those base images. Every single package, every single kernel, every single version that is pinned, we upgrade to the latest version. And this we produce, we push to the people to use. We are adding new images during this time, so if there is new version of Java, Python, Node.js, whatever, it's becoming available after the QPD. We are also deprecating images that we want to delete. For example, recently we deprecated Java 8. Deprecating, we call it just labeling as a deprecated. There is also some nice message added on build time. When you build deprecated image, you will see this image is deprecated. Don't use it, and link to the source code where is instruction how to progress. We're not deleting stuff immediately, so we are delaying breaking changes. On next quarterly patch day, we are deleting stuff that was marked previously, and we repeat it quarterly. Providing quarterly updates was, let's say, a big improvement, quite stable, but it's not enough. 3-month-old image is actually pretty old. It might have some security issues. So what we also did, we are providing automatic monthly upgrades. Those are triggered manually, but optionally we can just, click build and it's running. They are focusing on upgrading mostly operating system packages. So downloading fresh SSL, fresh Tomcat or whatever, and releasing as a patch level version, because we are not doing any big changes. This is happening monthly, but because we work on those images, they usually are pushed even more often. Yeah. At this point, human, from being pretty reluctant to push updates, we became pretty aggressive to push them. It might happen that during single day there will be 3 different updates of base images. It might happen that during the week there will be 3 of them. And if you think about development teams, you have to deliver something at the end of sprint and it's breaking for you. This might seem quite drastic, but we prefer to move forward than backward. And what we do to, let's say, provide relief in this situation, it's not actually an IT solution. We just provide good notification. So we usually know what will change before QPD. We know what languages, frameworks just arrived. So we send this information that that might arrive. And we remind you that last quarter we deprecated this, and we will delete it this time. Then QPD happened and we send notification again. This is what we eventually did, and we provide information how to progress with deprecation, with deletions, etc. And it's just that simple. The proper communication here is a key. Thanks to that, we no longer have requests to add something new because we are doing this periodically. They know that new languages, new frameworks, new versions will arrive pretty soon. So we don't have this kind of request, and because we notify what we are changing in front, they can plan it. It's business as usual for them. So just to summarize this, we push for latest instead of pinning the version, and we provide updates quarterly, then monthly, and even more often. Thanks to that, we provide really fast updates, upgrades to the production, because you always use latest. Every build will use the latest version of images, probably the patched, the secure one. People also get used to those iterations. If it's failing after our build, usually it happens that we have just few cases per month that it's failing. Why? I will tell later. There is something more to that. And this allowed us to move more forward. It doesn't happen anymore that someone pinned version of Docker image 2 years ago and it's still on production. There were other good practices, or for us actually not that good. And there is general recommendation to use build cache when you build Docker images. It might make your builds faster. This is good actually. But on the other hand, if you think, for example, about Node.js and packages.json, it's downloading a lot of stuff. Okay, it's downloading faster. But if you have this in cache and you build the same image every day for 2 weeks, it's still in the cache. Suddenly, cache is lost. It's just a cache. It might disappear. It might be expired. And you're losing the cache. You're losing the packages. If you didn't pin version properly in your framework, in your language, you're losing this information. Your project is no longer building. So it didn't work well for us. So actually, it was often causing something like it was working yesterday. It was working an hour ago. And development teams didn't know why it was working and why it's not working right now. Without build cache, we don't have these issues. As alternative, we just provide alternative ways to cache artifacts, or just use Artifactory as a proxy to cache packages, either from NPM, Maven, whatever. We also have additional functionality in Jenkins that allow to do that. So again, I don't recommend to use build cache. Like, especially if you have multiple instances of services, synchronizing it's pointless, and it might happen that your build will be running just on one node of the Jenkins because there is a cache. It's not working well for us. Okay, let's go forward. You said that you use volumes Corporate stuff, sorry. You said that you use not volumes, that you use Docker. But do you use volumes? Anybody use volumes like that? Yeah, I see. So one person I see actually. Why to use them? There's just one line in the documentation about this, and the most important part about it is that after you mark a directory as a volume, it's like being frozen. Every time you change it after declaring a volume, it's just being cleared. So it's perfect way to mark any places where garbage might collect. So if you are downloading packages, they will be left in those directories, right? In var cache yum, var cache apt, and they will be pushed to your production. For what? It's just some of the few hundred megabytes that you push for nothing. It's also quite popular to clean them. That's what good practice. So you should always clean, apt clean or remove manually. But when you actually declare the volume, you don't have to do that. It's done automatically. And now consider again 300 developers. How many of them will clean those packages? Small percentage will do that actually. They know it, some of them will do this. Most of them won't do this. If you use volumes, problem solved. Then something about layers. On the right side, there is just a short dump of Nginx, official Nginx Docker base image. As you can see, there is one run and a lot of bash commands. This is the recommended way of doing this. Is here anybody who think it's easy to read, easy to follow? Don't be shy. No one. So why it's recommended way actually, you know? The problem is that every run, every copy statement is producing another layer. Layers are slowing down downloads, and because of that, your container will be starting slower. That's the case why it should be used like that. And general recommendation is that you should reduce number of layers. Many people add at all costs. I don't believe that. And what we do, we add as many runs, copy statements, as many layers as we want. Some of you, some purists might think, but those are layers. But does it really matter? If we are talking about base images, there are base for, in our case, 1,500 different applications. So it's quite probable that our base image is already in the cache on the server. Even if it have 80 layers, they are not downloaded. Docker is just checking, yeah, I have this layer in cache, I have this, done. Maybe it's slightly slower. From our tests, this slowness was measured in seconds. We don't have applications that are let's say spinning a lot of containers in short period of times. Most of them are long running, so it doesn't really matter if they are starting 2 seconds longer. What we do to reduce the number of layers, we use experimental option that is available in Docker to squash them. What squash do is looking like that. You declare as a from, for example, Ubuntu image. You do whatever you want to. You build with squash, and you finish with just one layer. It is experimental option. It was experimental 5 years ago, and 5 years ago it was also quite stable. So I use it for quite a long time, and it's providing, let's say, best value for the effort. There are some shortcomings. If you use squashing, it's producing additional layers at build time. So when you use build cache, which we don't, it will be producing a lot of rubbish in your cache which is no longer used. So you have to measure that. You have to decide on your own if it's something that is working for you or not. And because it's producing additional layers, actually your builds will take double the size, pretty short. So you have to keep attention on housekeeping. In our case, we are spinning separate container for every build, separate Jenkins agent for every build, and it's destroyed at the end of the build, cleaning automatically, no issues for us. So I recommend to use volumes for any temporary or cache locations, because this will not be stored in the base image. Actually, every single volume will be also a separate unnamed volume mounted on a file system in a different way than a layered file system, which is slightly faster. And if it might work for you, squashing also might reduce number of layers without all the complexity to remove those layers manually, reducing the runs, copies, and etc. Shortly about security. Many best practices advise to do some kind of security with images. Some kind, like scan them when you build them. But what would you gain if you scan them at the end of the build? You just build, you have the most possible fresh packages. Even if there are some bugs, you cannot do too much about that. You have to wait until the packages will be released, unless you actually can change something. Usually you can't. So what we did, we written a simple scanner. For that we use Trivy. Trivy is a Docker image scanner, really fast one, really nice one. It's working nice with Ubuntu, Red Hat, because it recognizes their internal CVE issues. Thanks to that, we can scan the whole platform, for example, at any time. All those applications that actually are running on production, we can scan them. Or we can just scan some specific images. You might remember, not that far, there was issue with Log4Shell, Spring4Shell, and probably other bugs. In such situation, we just use this scanner, and we know every single image on production that is deployed with those issues. This might be used by the teams or the security department. One more thing. Do we have here people that test Docker images? Okay, we have a lot of developers. Do you test your code? Hand up. Why don't you test Docker images? Like, it's artifact, it's like integration testing. And this is something, we have this question. We've been looking for something that might work for us, and actually there are no good frameworks to do that. There are some tools, most of them are pretty terrible to use. We figure out that we can use test infra plus PyTest framework, and test infra, it is a Python framework library that allows to test, for example, configuration management tools like Chef, Puppet, Ansible, or your infrastructure in the cloud. For example, if you want to check if all of your servers have proper DNS configuration, you write a short test in test infra, connect through SSH to all the servers, and you will know. Test infra have support for Docker, or some kind of it. So it was one of the targets. We've been looking for alternatives. There is something called server spec. It's based on RSpec, written in Ruby. My team didn't like Ruby. There were also some alternatives that use Ansible. But Ansible is used for configuration, and to use it for testing, it's just weird. It's tricky, it's unnatural. So we end up actually with test infra, and it wasn't easy. Theoretically, it had Docker support, but it was more intended to, for example, spin a Docker container, apply some Ansible playbooks on it, and then verify with test infra. it wasn't enough for us because we have to spin hundreds of containers in different configuration and verify if they have proper configuration. And that's not all, because you have to figure out, you have hundreds, or in our case, probably right now, even thousands of tests, hundreds of containers, and match them. So we tried with some kind of regex at beginning. It was pretty terrible. After a week, nobody know what we actually are matching. And eventually we end up writing a plugin for test infra with configuration where we have general patterns for base images, and they allow us to test them. How such tests look like? It's really easy to read. We have, let's say, a being of container, and on this container, test infra allow us to run tests that test if specific user exists, if specific file is executable, if, for example, service is running properly after we start the container. Those tests are easy to read, easy to understand, easy to follow, and they gave us huge confidence in pushing new stuff. So when I was asking if we don't push too hard, we do, but thanks to tests we can do that. Because if tests are not failing, we know that every single container will start, every service in it will work, it will be listening on proper ports, it will have proper logging format, proper unprivileged user, things like that. That's actually all of the tricks I have for you. And if there is just one thing I can ask you after this presentation, I would say don't be afraid to challenge best practices, and you have to be aware that those best practices might be written by people with different assumptions, with different environment, different people that they work. What you can actually do, you know, probably one of those graphs, that's what DevOps guys do for some time with applications. When you have a problem, you can just choose propose best practice as some kind of promise of solution, POC it, run something that will check it, validate if it's working for you. For us, for example, use of the pinned version of Docker images wasn't working because we have issues with security of images on production on that. They were just too old. Updates were not propagating fast enough. Sometimes you have to slightly adapt this best practice for your environment, for your team, or scale it properly. And when you finish, you can start with another one. Just don't try too much, too hard, you know. It's probably not gonna be a nice place if you change too many things at the same time. That's all that I have for you today. I hope that you enjoyed. And if you have any questions, we have some time for that. Eventually, you can also spot me somewhere around Zupla's booth. Any questions? Yeah.
Do you use Docker files from Docker Hub or only your own?
We use base images only for operating systems from Docker Hub, like CentOS, Ubuntu, and the whole tree we built on our own. We want to have full ownership on those images.
You use those from Docker Hub. Do you use signed Docker files?
Not yet. Yeah, I have this on my to-do list. Yeah, this.
How much per average test infra is adding to starting application?
How much on average?
Let's say test infra is adding when you are running tests on your images. How much it adds to starting?
It's not used on a startup. So at the end, when we finish building images, we have this huge list of 200 images, and we match them. We start specific container, and we are running test infra inside of this container, verifying all the stuff, closing and destroying. So it happened during the build time, and it take for all the images around 30 minutes. That's why we build them in chunks. No, no, it's just during the build time. Yeah, please. We had one. Like, we had one until, I don't remember, 25, 30, but with 50, the whole build was taking from hour and a half to 2.5 hours. It's quite long. And if it failed after 2 hours, it wasn't enough. So right now, I think we have 6 or 7 repositories. So for example, we have Java dedicated images, Java, Tomcat, things like that, Python dedicated, Node.js, Erlang. We group them in smaller repositories. Those usually build below 10, 15 minutes. Yeah, please. Yes. Yeah, I can. So when we push for latest because we want updates to hit production. Every time you build and you fetch latest, you actually are, let's say, covered from this security. You have the fresh image, fresh operating system, latest updates. If you use pinned version, you don't have that. But sometimes it might cause some issues that, new version of one package might be problematic for your application because you have to update some kind of library. It happened. Thanks to those tests, we run every application, and at least we know that we didn't make stupid mistakes, typos, changing permissions. Thanks to that, we have more confidence pushing for the latest. After the QPD, the big one update, when you're updating everything, and think about those 150 deploys per day, 1,500 applications that we have, and we usually have less than 10 requests to support because something is not working during the next week after the QPD. It's completely manageable thanks to the tests because they are just testing a lot and it's usually working. Per QPD. And during those monthly, I think I remember just one situation with SSL, but it was changing something in protocols and just application require more updates. But yeah, it's a really good trade-off for us. Thank you. Okay.